Let's continue our lesson on solving one-step inequalities. Last lesson, we worked on solving one-step inequalities by adding or subtracting. Today we're going to work on one-step inequalities, solving them by multiplying or dividing. Now, when we were working on adding and subtracting, they were really very similar to solve an inequality as it was to solve an equation. When you solve by multiplying or dividing, it's very similar when you multiply or divide by a positive number, but there is a major difference when we multiply or divide by a negative number. So let's start with positive numbers first, since that is going to be the easiest for us. The notes that you had from last lesson, where we added or subtracted to solve inequalities, have the very beginning of these notes at the bottom. It says multiply or divide by a positive number, multiplication and division properties. So when you multiply or divide each side of an inequality, by the same positive number, the inequality remains true. Let's look at some examples. In our first example, we have 4x is less than 4. Now, recall that when we had an equation where we multiplied 4 times x equals 4, we would divide both sides by 4 in order to solve the equation. You're going to do the same thing to solve an inequality. So these 4's will cancel out, and we get x is less than 1 as our answer. On number 2, this time we have 7 is greater than or equal to h divided by 14. Because we're dividing, we're going to multiply both sides by 14. So these two will cancel out. We'll multiply 14 times 7, get 98 is greater than or equal to h. Now, one thing that we talked about in our previous lesson is that we don't want the variable to be on the right side. In order to plot this on a number line, it's a lot easier if our variable is on the left. So let's go ahead and move our variable to the left and our answer to the right. And remember that when we do that, we have to flip that symbol. So if you have a highlighter, you might want to highlight that we flipped the symbol, okay? Flip symbol. When move variable from right to left. It's very important that you remember that you can't just move the variable to the other side of the inequality like you can on an equation. You actually have to flip that symbol so that it has the same answer. So h is less than or equal to 98, and we talked about last week that means that any number that is less than or equal to 98 will make that inequality true. Go ahead and pause the video and take a few minutes to work the next two problems. Remember that in order to get credit for your notes, you have to actually work these two problems out the same way that we work the examples and bring them to class so that you can get credit for it. When you're finished working the problems, come back and we'll talk about multiplying or dividing by a negative number. Okay, let's talk about multiplying or dividing by a negative number. Now, up to this point, solving inequalities has been the same or very similar to solving equations. The only difference has been that instead of an equal sign, we have an inequality symbol, and we know that those inequality symbols mean that there's going to be more than one answer that will make the inequality true. So when we multiply or divide by a negative number, the multiplication and division properties say that when you multiply or divide, each side of an inequality by the same negative number, the inequality symbol must be reversed. You can write flipped in parentheses because we usually say flipped. Must be reversed or flipped for the inequality to remain true. This is not a difficult concept, but it's one that you have to remember and you have to think about each time you solve an inequality by multiplying or dividing. So let's take a look at some examples. Number 1 says 13 times a is greater than or equal to negative 26. Well, if you need to, you can highlight those variables in 1, 2, 3, and 4 so that you know what you need to get by itself or isolate in order to solve the inequality. So on number 1, we know that we need to get a by itself. In order to do that, we need to undo the multiplication by dividing. And so 13 divided by 13, we know that that's going to cancel out. We get a is greater than or equal to negative 26 divided by 13 is negative 2. And we did not divide by a negative. We divided by a positive 13, so we don't have to flip our symbol. So our answer is a is greater than or equal to negative 2. Let's take a look at number 2. Negative 8 is less than or equal to negative 4 times w. In order to get the w alone, we need to divide both sides by negative 4 to undo that multiplication. So this time we are dividing by a negative. If you want to, you can highlight that to show that we've divided by a negative number. So these two are going to cancel out and leave us with w on this side. Negative 8 divided by negative 4 is positive 2. But we have to flip or reverse that symbol from here. Let me get a different colored highlighter. From here to here because we divided by a negative number. So flip symbol, because we divided by negative 4, okay? Now, we've got one other little issue with this one, and that is that our w is on the wrong side. So we're going to put our w on this side, our 2 on that side, and that means we have to flip that symbol again. So I call that's sometimes a double reverse or a double flip. So this time we reversed it or flipped it because we moved the variable to the right. Or to the left, sorry. Flip symbol to move variable to the left. So this one we had to flip it twice. So you really have to be thinking about what it is that you're doing when you work these problems. Let's look at number 3. Number 3 says r divided by negative 2 is less than negative 2. In order to isolate r, or to get r by itself, we have to undo the division. So we're going to multiply both sides by negative 2. When we do that, these two cancel out. It leaves r by itself. And r is going to be greater than positive 4 because we had to flip our symbols because we multiplied by a negative number. Okay, so flip symbol because we multiplied by -2. Let's look at our last example, number 4. -36 is greater than or equal to -1/2 times x. Now on this one, we are going to undo the multiplication by dividing by -1/2. But you have to recall what happens when you divide by a fraction. When you divide by a fraction, you actually multiply by its reciprocal. So we're going to multiply both sides by -2. When we do that, this cancels these two out. We get 72 is less than or equal to x, because we had to flip that symbol when we multiplied by the -2. But then we've got our x on the wrong side, so when we move it, we're going to flip that symbol back, so it's once again one of those double flipping situations. I want you to take a couple of minutes and pause the video, and I want you to look at each of the practice problems down below. You've got 4 of them. In fact, we can go ahead and highlight the variables if you want, so you know what you have to isolate. And I want you to take your time and review the examples above in order to solve these problems. Now remember, if you multiply or divide by a negative, you have to flip or reverse your symbol. And also, there are times when you have to flip or reverse your symbol twice because you had a variable on the right and you needed to move it to the left. So, for example, in number 2, if you look at that, you know you're going to divide by a negative, which means you're going to flip your symbol once. But then your d, or your variable, is on the right side of the inequality, and when we move it to the left side, we're going to have to flip our symbol again. So go ahead and work these problems using the examples above for some help, and then bring these problems to class so that we can go through them and you can get full credit. All right, let's look at our last page of notes. It says to graph the solutions from your practice problems. So your practice problems are the ones that we just went over from the previous page of notes, the 4 problems where we multiplied or divided by a negative. So what I want you to do is to take some time to go ahead and graph the solutions from those problems on this number line. Let's look at one example together. So let's look at number 2 from the example problems on the page before. Number 2 said -8 is less than or equal to -4 times w. We solved it, and our answer was w is less than or equal to 2, because if you recall, we had to flip that symbol twice in order to, number 1, divide by the negative number, and number 2, move the variable to the left. If you don't move the variable to the left, it's going to make graphing the solutions on the number line much more difficult. So be very careful, get that variable moved to the left, and make sure that you flip that symbol to do that. So let's go ahead and put a 2 on our number line, and then we're going to put one number greater than 2 and one number less than 2. And recall that when you have a less than or equal to, you're going to have a closed circle, because it means that that 2 is going to be included in your solution set. And then we're going to draw our arrow to the left, because all of the numbers to the left are less than or equal to 2. Also remember that your symbol is pointing to the left, so that helps to know which way your arrow is supposed to point. Over here on the side, let's just remind ourselves that if it's greater than or equal to, or greater than or less than, sorry, you're going to have an open circle on your graph. If it's greater than or equal to, less than or equal to, you're going to have a closed circle on your graph. So just as a reminder, you might want to write those down to remind yourself to do that. Go ahead and finish those 4 problems, and then you can bring those to class tomorrow to get credit, and we'll go through them together.